Good evening, everyone. So this is the exercise 12. A tank A with a volume of 1 meter cube contains water with a specific volume 0.5 at 200 kilopascal. It is connected through a valve somehow here maybe. This is tank A. It's connected to another tank B. And tank B contains a 3.5 kilogram of water at that much of pressure and temperature. So tank A, volume 1 meter cube, a specific volume of 0.5 meter cube per kilogram, and pressure of 200 kilopascal. Now the two tanks are separated by a valve. Tank B contains 3.5 kilogram, pressure of 0.5 megapascal, so that is 500 kilopascal, and temperature of 400 degrees Celsius. Now, as you can see, we have two independent intensive properties in both tanks. This allows us to calculate various properties. So let's see what's the question. The valve is now opened and the two tanks come to uniform state. Find the specific volume, so the final specific volume. Now we know that a specific volume is the volume final over mass final. Now when the valve opens, this means if we assume the connection volume is minimal, then the final volume will be the volume of tank A plus the volume of tank B, and the mass final will be the mass of tank A plus the mass of tank B. Let's start first working out the masses, because mass of tank B is given 3.5. So I can find mass A because we have already the volume of A and the specific volume of A. So the mass of tank A is the volume of A divided by specific volume of A. So this is 1 over 0.5. So this is meter cube over meter cube per kilogram. This means this is 2 kilograms. So now we have mass of tank A, and we already have the mass of tank B, which is 3.5 kilogram. So now we have the total mass, which is mass A plus mass of B. Now let's work out the total volume. The volume A is given, so VA is 1 meter cube, but I don't have volume B. You may notice that the pressure of tank B and temperature of tank B both were given before the valve is opened, so we could work out the specific volume of tank B. And if we calculate the specific volume of tank B, then having the mass, I can work out the volume of B. So in order to find the volume of tank B, let's first find the specific volume of tank B before the valve is open. Okay, so since we are dealing with water here, so we're going to look at B1 table. So we will be looking at the pressure entry of 500. So 500 kilopascal is equivalent to a saturated temperature of 151.86. But in our case, the temperature is 400 degrees Celsius, much higher than this. Now the only state that it could have both 500 kilopascal as pressure and a temperature of 400 is when we are in the superheated region. To explain this, let's draw the pressure versus specific volume entry. We are 500 kilopascal. This is the dome. Our temperature constant lines is here. Our Tsat 151.86. However, our temperature is at 400, so we are at a higher temperature line here. And the only way we could have a 500 kilopascal at 400 Celsius is when the intersection occurs here, which is the superheated part. This means we have to use table V13. This is the table again. So going to the superheated table, that is the superheated table at pressure of 500 kilopascal. This is the 500 kilopascal at 400 degrees Celsius. In the first column, this is equivalent to 0.61728 meter cube per kilogram. So implies a specific volume of tank B before the valve opens. This is 0.61728 meter cube per kilogram. So the volume of tank B in this case will be mass of B times the specific volume of B. So this means, using the calculator, this is a 3.5 kilogram times the specific volume previously found of 0.61728 meter cube per kilogram. So the volume calculated is 2.16 meter cube. Now we have the volume of tank B, and we already have previously the volume of tank A given, so we can simply use the first relation to calculate the final specific volume. We'll do the calculations over here. So specific volume final is volume of A plus volume of B before the valve is open. Dividing this by the total mass, the mass of A is 2 kilograms and the mass of tank B is 3.5. So the final specific volume is calculated as 0.57 meter cube per kilogram.